Let us discuss f of n equal to n square minus n. Prove f of n is of order theta n square. See the definition of big theta. F of n is sandwiched between c1 into g of n and c2 into g of n. F of n is less than or equal to c2 into g of n. F of n is greater than or equal to c1 into g of n. For all values of n greater than or equal to n0, c1, c2, n0 are positive functions. F of n and g of n are non-negative functions. Here our f of n is n square minus n. Our g of n is equal to n square. Let us try to calculate c1 and n0. How we know? F of n is greater than or equal to c1 into g of n. Our f of n is n square minus n. It is greater than or equal to let us take c1 is equal to 1 by 2 of g of n, or g of n is n square. At n0, at n equal to n0, n square minus n is equal to 1 by 2 n square. N square minus 1 by 2 n square is equal to n. N square minus 1 by 2 n square means n square into 1 minus 1 by 2 is equal to n is equal to 1 by 2 n square is equal to n and n equal to 2. You will get n0 is equal to 2. Okay, you can solve this equation like this and obtain this n0. Let us try to guess this while considering different values of n. N, then 1 by 2 n square and n square minus n. Let us put n equal to 1. It will be 0.5 and this will be 0, and when n equal to 2, it is equal to 2 and this also 2. When equal to 3, it will be 4.5 and this will be 6. And n equal to 4, it will be 8 and this will be 12. Okay, here you can see our condition n square minus n greater than half n square. This is wrong. Here this when n equal to 1, this condition is wrong, and when n equal to 2, they are equal. Okay, and for all values greater than 2, this inequality is satisfied. So n0 is equal to 2. We are considering c1 into g of n. The c1 into g of n touches here as well as here. So after this f of n, it is in red. It is less than c1 into g of n after this point. So this cannot be considered. Let us consider this one. n0 for c1. We got c1 is equal to 1 by 2 and n0 is equal to 2. Next, let us go for C2 and N0. We know f of n, it is less than or equal to C2 into G of n. That is n square, this is the upper limit. N square minus n is less than or equal to n square. N square minus n, it is less than or equal to n square. Here you can see this C2 is equal to 1. Okay, let us try to guess the n0 by considering different values of n square minus n and n square. N is equal to 1, this is 0 and this is 1. N square is greater than or equal to, okay, this is correct. When n is equal to 2, this is 2 and this is 4, okay, this is also correct. When 3, it is 6 and this is 9. So we can fix our n0 equal to 1. For all values greater than 1, this inequality is satisfied. So n0 can be 1. Touches this f of n in 2 points, one here and one here. Okay, let's take this one because after this point, this C2 into G of n is less than f of n because it goes through this way or below this f of n. So this will be our n0 in this case. It is 1. Then what will be our final answer? We can fix C1 equal to 1 by 2, C2 is equal to 1, and after this n equal to 2, these two conditions are satisfied. So this will be our final answer. We can't take n0 is equal to 1 because see this section, our f of n is less than C1 into G of n. We should get f of n is greater than C1 into G of n, and this happens in this portion when n is greater than or equal to 2. We have obtained a C of 3 positive constants C1, C2 and n0. Hence f of n or n square minus n is of order Big-Theta n square. C2 into G of n is the upper bound and C1 into G of n is the lower bound.